Welcome to CO451 Networking. This is week 8. This week we're looking at basic router configuration and ICMP, Internet Control Message Protocol. The modular objectives. This week we're doing basic router configuration and ICMP. The objectives are to implement initial settings on a router and end devices and use various tools to test network connectivity. We'll be looking at how to configure initial router settings, configure initial routing settings on an iOS Cisco router, configure interfaces, configure 2 active interfaces on a Cisco IOS router, configure the default gateway, configure devices to use the default gateway, ICMP messages, explain how ICMP is used to test network connectivity, ping, traceroute testing, using ping, traceroute utilities to test network connectivity. Configure initial router settings. Basic router configuration steps. Configure the device name. We use the hostname command followed by the name that you'd like to use for the router. This is normally written in all capitals. There can be no spaces, so an underscore is normally used instead. Short and sweet, and obviously relevant to the router that you are naming when you use a host name. Secure privileged exec mode. This is enabled with the enable command, so we can put the command for enable secret. This is in the global configuration mode, followed by the password that we would wish to use for the enable command. So essentially, you can't access the privileged exec mode without using enable with a password of your choice. So the password again should be strong and secure. Secure user exec mode. This is configured with the command line console 0 to enter the configuration mode for the console port. We then put a password on it with password, followed by the password that we want to use. Again, a secure password following normal secure password methods. And then we activate that with secure login with the login command. And that's all within the configure for the line console 0 port. Secure remote telnet and SSH access. That's configured with the line VTY04 command, which actually gets us to the configuration settings for the line on the virtual terminal connections into our router. And again, we have to give it a password, so we use a password command followed by a strong password. And then we use login to activate the secure login, local login. And that's then followed by the command transport input, followed up by either SSH or telnet or both if you wish to enable secure login for SSH and telnet. If you don't do a secure remote login settings in this way for telnet or SSH, then you will not be able to get remote access to your device. So you have to have enabled the password and secure login and transport mode, input mode, in order to actually log in remotely to and manage a router device or switch. Encrypt all plain text passwords. That's done with the service command. So service password encryption. Again, in global configuration mode, that simply encrypts any password that would be normally stored in plain text or are currently stored in plain text become encrypted. Provide legal notification and save the configuration. So the legal notification is via the banner with the message of the day. So it's banner message of the day, MOTD, followed by normally a hash, and then the message that you want to put in, followed by another hash to indicate the string that you're adding. And this normally says authorized access only to indicate that that if anyone sees this, they are on a router that has to have authorized access, i.e. if they're there unauthorized, then they have been told that they needed authorized access to access it. So legally they are know they're trespassing and know that they are illegally accessing this device. To copy your configuration, it is copy command with running config to the startup config. So you copy the running configuration, which is stored in RAM, to the startup configuration, which is in NVRAM, in order so that if the device is powered down, this router is powered down, then when it starts up again, it will use the startup configuration that's there and copy it to the running configuration. Now, if that's been saved from the running configuration to startup configuration, then obviously it will start up again as it currently is. So any changes you make are always saved in the running configuration file, but you need to save it to the startup configuration file to ensure that if the power goes down, then that configuration is saved and used for the next startup. Basic router configuration example. Commands for a basic router configuration on R1. Configuration is saved to NVRAM. So these are the commands in action. So we can see that under global configuration mode, we're putting in a host name of R1. We're enabling the secret for the enable command, and we're using the password class. We're accessing the line console 0 port, and we're putting a password of Cisco on the port. Activating the secure login with login. Then we're going to the line VTY04 command, so we're accessing the virtual terminal ports 0 to 4. Again, we're putting a password on those with the password of Cisco, activating secure login, and then moving to the activate transport input SSH and telnet. So both SSH and telnet can be used with secure login and the password of Cisco on this particular device. We've activated the service for password encryption, so any of those plain text passwords of Cisco and the class, that would be then encrypted within the running configuration. And finally, we're putting on our legal notice, banner MOTD, authorized access only, to indicate that this device is protected and needs authorization to access it. And then finally, right at the bottom, we're copying the running configuration to the startup configuration so that this configuration is then saved within NVRAM. Packet tracer exercise, configure initial router settings. So this exercise just takes you through verifying the default router configuration, configure and verify the initial router configuration, save the running configuration file. So this is a really important packet tracer exercise to do in order to get your practice in with configuring initial router settings. Configure interfaces. Configure router interfaces. Configuring a router interface includes issuing the following commands. Interface, followed by the type and number of the interface you're trying to access. So this could be Gigabit Ethernet 000 within the router. Adding a description. It's a good practice to use the description command to add information about the network connected to the interface. So it's important to put description and then followed by a textual description of what the interface is accessing into. So if it's accessing into the local area network, then you would put access to local area network, or however you've divided your subdomains and parts of your network. So it needs to be a textual description that is useful to anybody who sees this interface and wants to know where it connects to in the text description. The no shutdown command again activates the interface. By default, router interfaces are turned off. To turn them on, you have to take them out of shutdown mode. So they're essentially shut down. So you have to take them out of shutdown, which means you say no shutdown. No is a standard command to undo something within the interface. So no shutdown means that it will take the shutdown off and bring it back up into working order. So no shutdown is a key command. We also have the IP address command here for adding an IP version 4 address. So with IP address, it's then followed by the IP version 4 address and then the subnet mask that goes with that IP version 4 address for the interface. If you wish to put an IP version 6 address on the interface, then it's IP version 6 address as the command, followed by the actual IP version 6 address with the / and then the prefix length to follow it. So IP version 6 doesn't have a subnet mask, but it has a prefix that's added on to the end. So configure router interface examples. Again, the commands to configure interface gigabit 000 on R1 are what we're looking at here. So in our diagram, we have this R1 router. It has 2 gigabit Ethernet interfaces. They are numbered as 000 and 001. So this is the configuration for 000. You can see that in the configuration we're going into the interface. So interface gigabit Ethernet 000 gets us to the interface configuration for R1. We're putting a description on, so we put description and then followed by link to local area networks or to LAN. That tells me that that's the local area network this link is connecting onto, so that's useful. Followed by IP address of 192.168.10.1. That's then the interface out of that local area network. So this is actually the default gateway router we're seeing here, and 192.168.10.1 is the interface address, which will be also the gateway address for PC1. The subnet mask for this is 255.255.255.0, which conforms to 24 1-bits, so that's /24 as it's shown within the diagram. IP version 6 address is also being added, so the IP version 6 address for this is 2001 db8 acad 10 and then 1, and it's /64 as the prefix length for this particular address. No shutdown to bring it out of shutdown mode and activate it, and when we do that we should see that the interface itself becomes up and changes state from down to up again, and the line protocol is also active. So the line protocol indicates it's connected on that particular interface. That if you get the interface powering up and down, then or down and up, sorry, then but without the line protocol, then you know that you haven't actually got a connected cable within that router. So it's quite important these little messages that come up into the interface here, so that we can see what state the router interface is in at that point when we issue our no shutdown command. These are the commands to configure the interface for gigabit Ethernet 001, again on R1 as well. So again, we've gone into that interface. We're going interface gigabit Ethernet 001. So it's important that we know which interface we're on. There's nothing to tell you within the command prompt exactly which interface you're accessing. It just relies on you knowing that you've gone into the right command and gone into the right interface number. Again, we're putting a description on. So this is linked to R2. The IP address for this interface is 209.165.200.225, followed by a subnet mask of 255.255.255.252. That conforms to a /30, so 31 bits within that subnet mask. IP version 6 address is 2001 db8 FEED 224.1, and it's again /64 prefix. Again, we're issuing no shutdown in order to bring that interface up out of shutdown mode. And again, it changes states from down to up to indicate that it's powered up and active. And the line protocol also changes to up as well, indicating we've got a connection and an active line from that interface. So verify interface configuration. To verify interface configuration, we need to use the show IP interface brief command and the show IPv6 interface brief command. So if we're looking at IP version 4 configurations, then it's show IP interface brief. If we're looking at IP version 6 configurations, then it's show IP version 6 interface brief. We can see the two commands being used here. So show IP interface brief gives us the 2 gigabit Ethernet 000 and 001 interfaces within the list, and we can see the IP addresses that have been assigned to them and that they are up and running, and the protocol is up as well. We can also see IP version 6 interface brief, the IP version 6 addresses that have been added to them. The FE80 IP version 6 address, that is a linked local address. So with gigabit Ethernet 000 and 001 there in their setups, we configured them with 2001 db8 addresses, but the FE80 addresses are automatically assigned as part of automatic procedures within IP version 6. As soon as that's enabled on an interface, those addresses are created as linked local addresses. And we'll talk more about that when we talk about IP version 6 in a bit more detail. Configure verification command. So this table summarizes show commands used to verify interface configuration. So show IP interface brief and show IPv6 interface brief. We've just seen those, but they display all interfaces, their IP addresses and their current status. So that's a useful way of verifying the current setup of an interface. Show IP route and show IPv6 route. They display the contents of IP routing tables stored in RAM within root or device. So again, two different, same command, but for IP version 4 and IP version 6. Show interfaces displays statistics on all interfaces for the device. Only displays the IP version 4 addressing information though. Show IP interfaces displays IP version 4 statistics for all interfaces on the router, and show IPv6 interfaces displays IP version 6 statistics for all interfaces on the router. So again, these are various different views that you can get to display important information about how the interface is being set up and what's on the router. So if I was looking at a router for the very first time or a switch, I would actually be using these commands to try and find out about how the configuration is currently set before I do anything to it. So view the status of all interfaces with show IP interface brief and show IPv6 interface brief. So we have two examples here on the R1 router. So show IP interface brief, and we can see there we see gigabit Ethernet 000 and 001, and we see their settings again showing the IP addressing for them, and the fact that they're up and running and the protocol is also up. And we also see the settings for show IPv6 interface brief, and again we can see the IP addresses for those. Display the contents of IP routing tables with show IP route and show IPv6 route as we've got here. So if you want to see the routing tables on a router, show IP route in the privileged exec mode allows us to see that information, and we can see both for IP version 4 with show IP route and IP version 6 route gives us the IP6 routing table. We can also display all the statistics for an interface with the show interfaces command. So show interfaces on gigabit Ethernet 000 gives us all the details about statistics about what's been going through gigabit Ethernet 000 in this case. So it tells us it's up, it tells us the line protocol is also working, it gives me the MAC address, it gives me the description that we put in, linked to LAN. It tells me its interface address is 192.168.10.1/24 within IP version 4. It tells me something about it's working in full duplex, 100 megabits per second. It gives me various different statistics about its performance and the way it's working. So a very useful set of information can be displayed here about the interface as a whole. We also have the way to display other detailed statistics with show IP interface, and that gives us again gigabit Ethernet 000, and again we can see more details about that particular interface. So if we want to display IP version 6 statistics for a router interface with the show IP version 6 interface command, we can do that as well. So here we can see again gigabit Ethernet 00, and again we can see that the interface itself is up and running, the protocol's up. We can see that link local address is FE80 address there. We can also see the global unicast address of 2001 DB8. We can see some of its multicast groups that it's joined, which we'll talk about in more detail at another point. And we can see that its maximum transmission unit is 1500 bytes MTU. Configure the default gateway. So the default gateway is used when a host sends a packet to a device on another network. The default gateway address is generally the router interface address attached to the local network of the host. To reach PC3, PC1 addresses a packet with the IP version 4 address of PC3, but forwards the packet to its default gateway, the Gigabit Ethernet 000 interface on R1. So, special note, the IP address of the host and the router interface must be in the same network. So it's really important that the default gateway that we are using is on router 1 on that interface. Gigabit Ethernet 0001 is our way out of the network for PC3 and PC4, and Gigabit Ethernet 000 is the interface that's the gateway out of the network for PC1 and PC2. So PC1 communicating with PC3 will use PC3's destination IP address, but the MAC address will be for the first hop anyway, will be for the Gigabit Ethernet address, Gigabit 0000 on router 1. So it will send to that default gateway address first in order to move its packets out of its network to the remote connection of PC3. So a switch must have a default gateway address configured to remotely manage the switch from another network. To configure an IP version 4 default gateway on a switch, use the IP default gateway command followed by the IP address global configuration command for the default gateway router interface that you want to use. So it's really important that when you are setting up a switch, you give it a default gateway address and an address that you can access it remotely on, so that it can communicate, or you can communicate to it remotely over a network. So again, a really important packet tracer exercise that you should do, connecting a router to a local area network, and you'll display router information, configure router interfaces, and verify the configuration in that exercise. Once you've done that one, follow up with the troubleshoot default gateway issues. This little exercise will take you through verifying the network documentation and use tests to isolate problems, determine an appropriate solution for a given problem, implement the solution, test to verify the problem is resolved, and then document the solution that you came up with. So this again is another little important little packet tracer exercise that you should do. These packet tracer exercises are obviously located within the Blackboard weekly folder for this week, and they are self-contained and you can work through them. Another one, packet tracer, so basic device configuration. Again, complete the network documentation, perform basic device configuration on the router and the switch, and verify connectivity and troubleshooting of any issues that occurred. ICMP messages, so this ICMP stands for Internet Control Message Protocol. It's a workhorse protocol, so it's used for a lot of different things in the management of networks and the testing of networks. So we use ping, and ping uses ICMP in order to test end-to-end connectivity between devices. So we have two flavors of ICMP, so ICMP version 4 and ICMP version 6. Internet Control Message Protocol provides feedback about issues related to the processing of IP packets under certain conditions. So ICMP 4 is the messaging protocol for IP version 4. ICMP version 6 is the messaging protocol for IP version 6 and includes some additional functionality. The ICMP messages come common into both ICMP 4 and ICMP v6, include host reachability, destination or service unreachability, and the time exceeded. Just a quick note that ICMP version 4 messages are not required and are often not allowed within a network for security reasons. So that is something that we is for security on the network, you tend to deny ICMP version 4 messaging simply because it can be used in nefarious ways as well as a maintenance tool. Host reachability, so ICMP echo message can be used to test the reachability of a host on an IP network. In this example that we see here, the local host sends an ICMP echo request to a host. If the host is available, the destination host responds with an echo reply. So this is pinging across a network in order to find out whether you've got a connection between two ends. So H1 is communicating to H2 with an echo reply, and hopefully H2 will respond with an echo reply back to H1. So echo request, echo reply. An echo request has been automatically sent by H1, and H2 has already replied with an echo reply. So this is a sort of main use of ICMP messages in pinging end-to-end connectivity, host reachability. Destination or service unreachable. So an ICMP destination unreachable message can be used to notify the source that a destination or host is unreachable. The ICMP message will include a code indicating why the packet could not be delivered. So a few destination unreachable codes for ICMP version 4 are as follows. So 0 would mean net unreachable, 1 means host is unreachable, 2 means that a protocol is unreachable, 3 which indicates that a port is unreachable. There's a few similar codes for unreachable codes within ICMP v6. So then 0 is no route to destination, 1 is communication with the destination is administratively prohibited, there's a firewall in the way it's blocking, 2 beyond scope of the source address, 3 address unreachable, and 4 port unreachable. Just need to note that ICMP v6 has similar but slightly different codes to for destination unreachable messages compared to ICMP v4. So some improvements made and some changes made when ICMP or IP version 4 was redesigned as in the sense of ICMP version 6 was redesigned for ICMP IP version 6 protocols. So these particular codes indicate various different information back if there is a problem with the end-to-end connectivity between either the service or destination is unreachable. Time exceeded, so the time to live TTL field in a packet, as we said before, is decremented each hop we go through. So decremented to 0, and ICMP v4 time exceeding messages is then sent back to the source host. So when it's runs out of host hops, then that particular ICMP with the TTL, the time to live field is decremented to 0. Then a message is sent back to the source host. ICMP v6 also sends a time exceeded message, but instead of the IPv4 TTL field, ICMP v6 uses IP version 6 hop limit field to determine if the packet has expired. So that also gets decremented, and when it hits 0, message is sent back. So just a quick note on this: the time exceeding messages are used by the Traceroute tool. So the Traceroute tool is really a great tool in order to send information back as it's passing through hops and destinations across the network. ICMP v6 messages. So ICMP v6 has new features and improved functionality not found in ICMP version 4, including 4 new protocols as part of neighbor discovery protocol, so ND or NDP. So messaging between an IP version 6 router and an IP version 6 device, including dynamic address allocation as follows. So we have router solicitation messages and router advertisements messages. Messaging between IP version 6 devices, including duplicate address detection and address resolution, again neighbor solicitation NS messages and neighbor advertisements messages. So these are new functions within ICMP version 6 that weren't there within ICMP version 4. Again, just a little note that ICMP version 6 neighbor discovery also includes the redirect message, which has a similar function to the redirect message used in ICMP version 4. So router advertisement messages, RAs, are sent by IPv6 enabled routers every 200 seconds to provide addressing information IP version 6 enabled hosts. Router advertisement messages can include addressing information for the host, such as the prefix and prefix length, DNS address, dynamic domain name server addressing, and the domain name. A host using stateless address auto configuration, that's SLAAC, so SLAAC, will set its default gateway to the linked local address of the router that sent the router advertisement. So SLAAC is kind of like a bit like DHCP for IPv6. So it allows you to set its own address details, linked local addressing, and the default gateway in this particular case to a local device. So PC1 in our example could pick up that information via using router advertisements and having information sent back to it, as in stateless address auto configuration, which will give it the default gateway to the linked local address of the router. So it gets its default gateway address from the router using SLAAC. So an IPv6 enabled router will also send out router advertisement message in response to a router service response message coming back, and or solicitation from a router, so a router solicitation message. In the figure, what you see here, PC1 sends a router solicitation message to determine how to receive its IPv6 address information dynamically. So R1 replies to the router solicitation with a router advertisement message. So PC1 sends a router solicitation message that says, hi, I just booted up. Is there an IPv6 router on the network? I need to know how to get my IPv6 address information. So this is like DHCP, Dynamic Host Configuration Protocol, for IPv4. We're kind of doing it within IPv6 here. So R1 will come back and reply with a router advertisement message. It will say, hi all IPv6 enabled devices, I'm R1, and you can use SLAAC, stateless address auto configuration, in order to create an IPv6 global unicast address. Prefix is 2001 DB8ACAD 1/64 is the prefix. By the way, use my linked local address of FE8080 1 as your default gateway for this particular network. So this is the information that comes back in the router advertisement. So it uses, so in IPv6 they use router solicitation and router advertisement messages and the stateless address auto configuration mode in order to set up onto a network, to connect to a network automatically and get IP addressing and the default gateway address via the network itself. So a device assigned to the global IPv6 unicast or linked local unicast address may perform duplicate address detection, so we call this DAD, to ensure that IPv6 address is wholly unique. So we have to have each device having a unique address within the local area network. To check the uniqueness of address, the device will send a neighbor solicitation message with its own IPv6 address as a targeted IPv6 address. If another device on the network has the address, it will respond with a neighbor advertisement, and again it will notify to the sending device that the address is already in use. So DAD is not actually required, but RFC request for comments 4861 recommends that DAD is performed on unicast addresses in order to ensure that you don't end up with address duplication. To determine the MAC address, the media access control address for the destination, the device will send a neighbor solicitation message to the solicited node address. The message would include the known targeted IPv6 address. The device that has targeted IPv6 address will then respond with a neighbor advertisement message containing its Ethernet MAC address. So in the figure, we have R1 sending a neighbor solicitation message to 2001 DB8 ACAD 110 asking for its MAC address. Ping and traceroute tests. So ping test connectivity. So the ping command is an IP version 4 and IP version 6 testing utility that uses ICMP echo request and echo reply messages to test connectivity between hosts and provides a summary that includes the success rate and average round trip time to the destination. If a reply is not received within the timeout, ping provides a message indicating that the response was not received. It is common for the first ping to timeout if address resolution ARP or neighbor discovery needs to be performed before sending the ICMP echo request. So essentially, if you do a ping on a new part of the network that hasn't been used before, you haven't gone to a particular destination, then you're more than likely going to get a non-return on the first ping. So it will probably fail on the first ping, but it normally by default sends about 4 pings. So the next 3 will hopefully come back and connect. So if you get that odd first one failing, it's simply because of ARP or ND, so neighbor discovery, or the address resolution protocol had to run, and that timed it out basically before it had a chance to complete. Pinging the loopback. So ping can be used to test the internal configuration IP version 4 and IP version 6 on the local host. So we ping a local loopback address. So this is like a home address. So 127.0.0.1 for IP version 4 and : 1 for IP version 6. So a response from 127.0.0.1 or : 1 indicates that IP is properly installed on the host. An error message indicates that TCP IP is not operational on a host. So it's really important just to test that your network interface card is actually responding and working correctly in the stack. And we can use this particular method of a local ping, loopback ping, in order to test the card. So before you investigate any problems that you might be appearing to have with a network connection, just do a quick test of the network interface card with a ping to its home address in order to ensure that it's not the card itself. So you can detect a problem with the network interface card if you just do this little test with ping to start with. Pinging the default gateway. So the ping command can be used to test the ability of a host to communicate on the local network. The default gateway address is most often used because the router is normally always operational. So a successful ping to the default gateway indicates that the host and the router interface serving as the default gateway are both operational on the local network. If the default gateway address does not respond, a ping can be sent to an IP address of another host on the local network that is known to be operational. So it's really important, again, we test that our default gateway address is able to respond, and we're able to connect out of our network segment here. So again, important that you ping after pinging the local loopback, that you also ping the default gateway to ensure that you've got connectivity beyond your network segment. Pinging a remote host. So ping can also be used to test the ability of a local host to communicate across an internetwork. So a local host can ping a host on a remote network. A successful ping across the internetwork confirms communication on the local network. Just a quick note that many network administrators limit or prohibit the entry of ICMP messages. Therefore, the lack of a ping response could be due to security reasons. Yeah, so security restrictions apply within networks to stop ICMP and pings happening and being used across network segments. So if you get a block to your ping request, you get no reply, it's not necessarily that the device is down. It could just be that that they're actually stopping you. You know, they've set up a firewall to actually block ICMP within that network segment. So it's not necessarily due to the failure of the device. It could just be that it's stopped for security reasons on the network segment. Traceroute tests the path. So Traceroute or Traceroute is a utility we use to test the path between two hosts and provide a list of hops that were successfully reached along that path. Traceroute provides a round-trip time for each hop along the path and indicates if a hop fails to respond. So an asterisk is used to indicate a lost or unreplied packet. This information can be used to locate a problematic router in the path or may indicate that the router is configured not to reply. So Traceroute makes use of a function in the TTL field, the time to live field in IP version 4, and the hop limit field within IP version 6, which is in the layer 3 headers along with the ICMP time exceeded message. So this is a way of checking a route through each router as a packet moves across a network and between networks. We can actually see information coming back via pings, that replies that are sent back to us, ICMP messages being sent back each time it goes through to record the address of the router that is passing us between one network and another. So this information is useful to us as a network administrator to see the pathway that packets take through our network. So the first message sent from a Traceroute will always have a TTL field value of 1, which causes the TTL to time out of the first router. This router then responds with a ICMP v4 time exceeded message, so that causes it to send that time exceeded message back. Traceroute then progressively increments the TTL field 2, 4, 3, 4 for each sequence of messages, which provides the trace with an address of each hop as the packets time out further down the path. So the TTL field continues to be increased until the destination is reached, or it is incremented to a predefined sort of maximum position. So we get an increase in the TTL as it's moving through in order to send back the address details of each hop as it passes through it. So again, we have a little packet tracer exercise which you need to do. So verify IP version 4 and IP version 6 addressing. Allows you to complete the addressing table documentation, test connectivity using ping, and discover the path by tracing the route. We also have a packet trace exercise on using ping and Traceroute to test network connectivity. So it allows you to test and restore IP version 6 connectivity and IP version 4 connectivity within the network. We have also a little exercise for ICMP to test and correct network connectivity. So using ICMP to locate connectivity issues, configure network devices to correct connectivity issues. So what we've gone over and hopefully learned this way, or we should learn this week by doing the packet trace activities and exercises to back this presentation up. Should be able to configure the name or device name, should be able to secure privileged exec mode, secure user exec mode, secure remote telnet and SSH access, secure all passwords in the configuration files, provide legal notification, and save the overall configuration. So that should give you a completed configuration or configuration of initial settings on a router. For routers not to be reachable, the router interfaces must also be configured. So using the no shutdown command to activate the interface must also be connected to another device such as a switch or router. For the physical layer to be active, there are several commands that should be used to verify interface configuration. So show IP interface brief, show IPv6 interface brief, show IP route, show IPv6 route, show interfaces, show IP interface, and show IPv6 interface. For an end device to reach other networks, the default gateway must be configured, so the IP address for the host device and the router interface address must also be in the same network. A switch must have a default gateway address configured to remotely manage the switch from another network. And to configure an IP version for a default gateway on a switch, we use the IP default gateway command followed by the IP address and global configuration under the global configuration command. So the purpose of ICMP messages to provide feedback about issues relating to processing of IP packets under certain conditions. The ICMP message is common to both ICMP v4 and IP version 6 are host reachability, destination or service unreachability, and the time exceeded. The messages between an IPv6 router and an IP version 6 device, including dynamic address allocation, include router solicitation and router advertisement. The message between IP version 6 devices include the redirect, similar to IP version 4, so that's neighbor solicitation and neighbor advertisement. Ping, used by IP version 4 and IP version 6, uses ICMP echo request and echo reply messages to test connectivity between hosts. Ping can be used to test the internal configuration of IP version 4 and IP version 6 on the local host. Traceroute generates a list of hops that were successfully reached along the path. And here we have a number of commands and terms that we've kind of used within this week's presentation. So just make sure you're familiar with these before moving on to next week.